in AgNO3 test, what do you get? In AgNO3 test, so we know that if there is a sodium chloride or sodium bromide, sodium iodide, sodium chloride reacts with, tell me, AgNO3, what it form? Corresponding silver halides. So tell me here, AgCl is formed, right? AgCl is a white PPT, here is AgBr pale yellow PPT, AgI is dark yellow PPT will be formed. Okay, but the question is, along with this halogen, if there is a nitrogen and sulfur also present, then what is the question mark? See, if nitrogen is present along with this, what is the possibility? So if the nitrogen present, if nitrogen present in organic compound, so what do you get? In Lessine test, you will get sodium cyanide, no? Sodium cyanide. Okay, then this sodium cyanide is also reacts with what? AgNO3. So therefore here, then the product is AgCN. This AgCN also white PPT. Okay, or if organic compound contain sulfur, that is sulfur is present in organic compound. If the sulfur is present in organic compound, tell me, in sodium fusion extract, what do you get? Sodium sulfide, Na2S. This Na2S also reacts with AgNO3. Then you will get AgS, silver sulfide, Ag2S, plus NaNO3, here also NaNO3. Now tell me, what do you understand by this? Come on, tell me. What do you understand by this? No, see what happened here. If there is only halogen is present, those halogens convert into this corresponding, it's Br, no, these corresponding halides, and these corresponding halides reacts with silver nitrate, they form corresponding silver halides. They are of course precipitates, it's alright. But the problem is, along with halogen, if organic compound containing nitrogen, if nitrogen is present, that nitrogen convert into sodium cyanide, that sodium cyanide also reacts with AgNO3, that forms white PPT. Then the product is, then the confusion is whether this white PPT is because of this or this. There is a confusion, right? If organic compound containing sulfur along with halogen, it gives the, of course, any one of this product, all right. Along with this product, this sulfide forms sodium sulfide in SFE. That SFE reacts with AgNO3, it forms Ag2S, black PPT. Then the question is, so you will get the PPT, whether PPT because of this or this. Again there is a confusion. That's what to do. So before doing the halogen test, before doing this AgNO3 test, what to do? We need to destroy, or we need to remove what? Cn minus, we need to remove S minus 2. So we need to destroy the cyanide ion, we need to destroy the H2, that is sulfide ion. Means we should remove it from the SFE. Then how do you destroy this? Therefore, now to destroy the sodium cyanide and sodium sulfide, it is the SFE treated with concentrated HNO3. It means this has to be done what? Before what? Silver nitrate test. So before silver nitrate test, we need to remove the S minus 2 as well as Cn minus. So therefore, before halogen test, that is a silver nitrate test, which is treated with HNO3, then what do you get? Cn plus H will get HCN, and H and sulfide and H will get H2S. Therefore, HCN and H2S, they do not react with silver nitrate. This is called destroying. When this has to be done? Before silver nitrate test. That's one important point in halogen, in detection of halogen. Okay, just pause. On made quantitative analysis of organic compound. Or estimation of elements. So in quantitative analysis, we estimate what percent element is present. So the difference between qualitative and quantitative is, in qualitative analysis we identify whether elements is present or not. For example, hydrogen present or not, carbon present or not. That is a qualitative. That is what identification, nothing but detection. But in quantitative analysis, hydrogen is present, we know it. Then we need to know what percentage of hydrogen is present. That is called estimation. Okay. So based on this, numerical questions only comes. Right. So therefore we need to understand what are the formulas. So that too particularly estimation of hydrogen and carbon. So if you understand estimation of hydrogen and carbon, the remaining all the methods are same except nitrogen. So that's what. Let us say first one, estimation of nitrogen and hydrogen and carbon by Levix method. Estimation of hydrogen and carbon by Levix method. So how do you estimate carbon and hydrogen by Levix method? Okay, see, in Levix method, a known mass of organic compound heated in a test tube with copper oxide. Let us take, it is a something W gram of organic compound. We know its mass. A known mass of organic compound which is heated with what? Copper oxide, CuO. Tell me, a known mass of organic compound, that is W gram of organic compound, is strongly heated with copper oxide. Tell me where? Carbon oxidized to carbon dioxide, hydrogen oxidized to water. Okay. Then how do you estimate water and how do you estimate the mass of the or weight of the carbon dioxide? Right. The amount of carbon dioxide can be estimated by passing or absorbing the what solution? CO2 by KOH, because KOH solution absorb the carbon dioxide. Right. Therefore, the amount of the CO2 formed or liberated can be estimated by absorbing KOH solution, and the amount of oxygen, that is water, is liberated or obtained by absorbing what? anhydrous calcium chloride. So therefore what we do here, so this is will get heated, and where carbon present in the organic compound convert into what? Carbon dioxide, and hydrogen present in the organic compound convert into water. Right. Now this carbon dioxide, now how much carbon dioxide is liberated? So you cannot get weight now directly. Therefore what to do? This carbon dioxide should be absorbed by the what? KOH. That means this CO2 allowed to pass over KOH, KOH solution absorb the CO2. So that then how do you know that KOH absorbs CO2? The weight of the KOH is increases. So initially something we take 1 gram of KOH. Then after the reaction you may get 2-3 grams. The increasing mass of the KOH is nothing but it is a mass of the CO2. Then how do you identify the mass of the water? So water is allowed to pass over anhydrous calcium chloride. Calcium chloride has more affinity towards water. It completely absorbs the water. So that by absorbing H2O, then what happened? The weight of the calcium chloride is increases. The increasing weight of the calcium chloride is nothing but the weight of the water is liberated or formed. Right? So therefore tell me. So a known mass, write one sentence. Known mass of organic compound. A known mass of organic compound heated with copper oxide, where carbon oxidized to carbon dioxide, comma, hydrogen oxidized to water. Next, the mass of the CO2 formed can be estimated by absorbing KOH solution, comma, the mass of H2O formed can be estimated by absorbing what? Anhydrous calcium chloride. Okay. Now take this. Let the mass of organic compound equal to W gram. Let us take W gram. Let the mass of organic compound is W gram, comma, mass of CO2 formed. Okay, mass of CO2 formed nothing but can I take increase in mass of what? KOH solution is equals to take X gram mass of H2O formed nothing but it is increase in mass of anhydrous CaCl2, so equal to you can take Y gram. So suppose X gram of carbon dioxide form are liberated, Y gram of the water is formed. Then we want percentage of carbon and percentage of hydrogen should be calculated. Okay. Now say for example, let us take CO2. Now 1 mole of CO2 contain 1 carbon, no? or 1 mole of carbon. One molecule CO2 has 1 molecule carbon or 1 atom carbon. Then its molecular mass is 44 gram. 44 gram of CO2 is equals to how many grams of carbon? 12 gram. 44 gram CO2 contain 12 gram carbon. Let us take now x gram of CO2 is liberated. Then x gram of CO2 contain how many grams of carbon? So that is nothing but mass of carbon, right? Mass of carbon in where? X gram of CO2. Tell me, what is the mass of the carbon in x gram CO2? X into 12 by 44, no? 12 by 44 into x. This is what? Mass of the carbon in x gram CO2. But actually we don't want to calculate mass. What do we want to calculate? Percentage. What is the percentage of carbon in W gram of organic compound? So therefore, now tell me, percentage of carbon in W gram organic compound. So W gram of organic compound containing what is the mass of the carbon? Percentage of carbon. So it is nothing but, can we take like this? Percentage of carbon in W gram of organic compound equal to mass of the carbon in x gram of CO2 divided by W into 100. That will know. So therefore, here I will write mass of the carbon in where x gram of CO2 divided by W. W nothing but mass of the organic compound into, since it is a percentage, into 100. Okay. Then percentage of carbon in W gram organic compound is also equal to, tell me, mass of the carbon in x gram of carbon dioxide, nothing but 12 by 44 into x. No, I will write 12 by 44 into, now x by W can be written. What is x? Is mass of CO2 formed, right? Mass of the CO2 formed, x is nothing but, yes or no, divided by mass of organic compound into 100. So this is the formula. Or percentage of carbon is equals to 12 by 44 into x by W into 100. So if you understand this, estimation of hydrogen same, even sulfur same, phosphorus same, all halogen same except nitrogen. Estimation of nitrogen ಮಾತ್ರ ಬೇರೆ ಇರುತ್ತೆ, ಉಳಿದಿಂದೆಲ್ಲ ಎಲಿಮೆಂಟ್ ಸೇಮ್ ಇರುತ್ತೆ. Formula is same. Ultimately you need to remember formula. Question comes on this only. Okay. So it is how you can estimate the percentage of carbon. So therefore, percentage of now hydrogen, calculation of percentage of hydrogen. Tell me, so how do you calculate percentage of hydrogen? To calculate percentage of hydrogen, you just tell me, if hydrogen present in organic compound which is converted into what? Water. Take the water, right? One water has how many hydrogen? 2 hydrogen. Therefore, what is the molar mass of water? 18 gram. What is the molar mass? Hydrogen 2 gram. 18 gram, 2 gram. Now tell me, 18 gram of water equal to 2 gram hydrogen. Then how much water is formed? Y gram. Then y gram of water equal to how many grams of water? Therefore, now tell me, what is the mass of hydrogen in where? Y gram water. So mass of the hydrogen in y gram water equal to, what is the formula? It is 2 by 18 into y. But we want percentage of hydrogen in W gram of organic compound. So percentage of hydrogen in W gram of organic compound equal to 2/18 into Y by W. Yes or no? So remember, this is directly. So where Y equal to what? Mass of the water. Y equal to no once again. Y equal to what or no? Y equal to mass of H2O formed or liberated. Here X equal to mass of CO2 liberated. It is by Levix method. So estimation of sulfur, halogen and phosphorus by Carius method. Okay. So estimation of halogen, let's see first sulfur by Carius method. Now all three methods having similarity. Now similarity is this. Let us take here a Carius tube. In the estimation of these three elements, right, organic compound, it is organic compound. This organic compound, of course, let us take W gram. A W gram of organic compound or known mass of organic compound is heated or treated with dilute nitric acid, fuming nitric acid, that is concentrated nitric acid in Carius tube, right. So therefore, now let us take first a estimation of sulfur. Tell me, in the estimation of sulfur, what is the process? A known mass of organic compound, let us take W gram, so which is treated with what? Concentrated nitric acid in a Carius tube. Where? So concentrated nitric acid is a oxidizing agent which convert carbon to carbon dioxide, and it also convert hydrogen to water. So we don't want water and this CO2, and it also convert the sulfur present in the organic compound into sulfuric acid. It oxidized sulfur to sulfuric acid. Now that sulfuric acid later it is treated with barium chloride. It forms a white precipitate of barium sulfate. That barium sulfate is washed and it is dried and later weighed. That means weight is taken. From the weight of the barium sulfate, the percentage of barium can be calculated. So sulfur can be calculated. Right, this is the process. So therefore, tell me what is the process, right? Short way. So estimation of sulfur by Carius method. So known mass of organic compound, treated with fuming nitric acid, which oxidizes carbon to carbon dioxide, hydrogen to water, and sulfur to sulfuric acid. Okay. Then now this sulfuric acid treated with now sulfuric acid treated with barium chloride solution, BaCl2. It forms barium sulfate. It is a white precipitate. So remember the color of the barium, because we will get even in a coordination compound also. Which of the following coordination compound can form the barium precipitate? Means white PPT with barium chloride. That means whichever complex compound has sulfate outside, cuprammonium sulfate, sulfate outside, that gives a white PPT with barium chloride. Okay, there was previous question appeared in NEET also. Right, so therefore, then sulfuric acid reacts with barium chloride, it forms barium sulfate is a white PPT. Now this barium sulfate is, it is filtered. It is a filtered, then it is washed and then it is dried. So after drying it, weight is taken. Okay, means it is weighed. Therefore, then now let the calculation tell me. In the calculation of barium, that is sulfur percentage of sulfur equal to, now see like this. Now here carbon, where carbon here, 12 by 44 into x by w. No, now tell me here, there what is the 12? Mass of the carbon in the compound CO2. Here what is the mass of the sulfur? There is only one sulfur, right? Sulfur mass is equal to atomic mass 32. 32 divided by what is the molecular mass of barium sulfate? So barium is 137, 32, 64. Do it. 233, right? Okay. So 233 into, next is what? Mass of barium sulfate. So how do you get mass of the barium sulfate? We have precipitate. Okay, we can take the weight now, divided by mass of organic compound. That is, what is the mass of organic compound we have taken? W into 100. Therefore, you have to remember formula. Formula only important. Okay, next is estimation of halogens by Carius method. In the estimation of halogen by Carius method, a known mass of organic compound, let us take W gram. So W gram of the organic compound taken in a Carius tube, and it is treated with same concentrated nitric acid or fuming nitric acid, but in presence of silver nitrate solution. In estimation of halogen, we add extra is AgNO3. I'll tell you why. Okay. Now tell me. Now in this process, what happened here? A known mass of organic compound, first it is treated with what? Fuming nitric acid. This fuming nitric acid, concentrated nitric acid, convert what? Oxidizes carbon to carbon dioxide, hydrogen to water. This is as usual. But if organic compound containing nitrogen, which is converted to what? Not nitrogen, sorry, halogen. If organic compound containing halogen, which is converted into corresponding silver halides. Why? We are adding AgNO3. Okay. Therefore, since we are adding AgNO3, if halogens are present, that halogen reacts with Ag, okay, which gives us to what? Ag, AgX, silver halide. Okay, so silver halide is a precipitate. Silver chloride has white PPT, silver bromide pale yellow PPT, silver iodide dark yellow PPT. So therefore, these precipitates are separated, they washed, they dried, and they weighed. So weight will be taken. Okay, now this is the process, but we focus on only what? Formula. Then how do you estimate chlorine? Tell me. Estimation of chlorine. Chlorine, bromine, iodine. Suppose here chlorine is present. Chlorine plus silver will get silver chloride. If the bromine is present, which is gives silver bromide. If iodine is present, which gives silver iodide. Now tell me, so what is the formula to estimate the silver? That is chlorine. You can take same AgCl, right? AgCl has how many chlorine? 1 chlorine. Okay. Then tell me, what is the mass of the AgCl? Cl is 35.5 and Ag is silver 108 plus 35.5, 143.5. Okay. Then tell me, what is the percentage of chlorine? Percentage of chlorine equal to, like similar to this formula, 35.5 divided by 143.5 into mass of AgCl divided by mass of organic compound, that is nothing but W. That's it. Next, similarly, percentage of bromine. So atomic mass of bromine is 80, right? Chlorine is 35.5, bromine is 80, iodine is 127. 80 by 188 into mass of Ag Br formed divided by mass of organic compound into 100. Next, percentage of iodine. 127 divided by 2, 35 into mass of Ag I formed divided by mass of organic compound into 100. Okay. Estimation of phosphorus. See, all these we are studying by Carious method. Tell me, in all Carious method, what is the common? Organic compound should be treated with concentrated nitric acid. This is the common. So why it is treated with carbon? Why organic compound is treated with concentrated nitric acid? Concentrated nitric acid only can oxidize carbon to carbon dioxide, water, hydrogen to water, and sulfur to sulfuric acid, even phosphorus to phosphoric acid, because it is one of the strongest oxidizing agent, HNO3. Okay. Now here also same process. So what is the process here? A known mass of organic compound taken in a test tube, right? This is organic compound. Organic compound, its mass is known, let us take W gram, and which is treated with fuming nitric acid. Tell me. So a known mass of organic compound is treated with fuming nitric acid, which oxidizes carbon to carbon dioxide. It also oxidizes hydrogen to water. And if organic compound containing phosphorus, phosphorus oxidizes to phosphoric acid, orthophosphoric acid. Okay. Therefore, if organic compound containing phosphorus, which oxidizes to orthophosphoric acid, H3PO4. Now tell me, this H3PO4 is not PPT, no. Since it is not a precipitate, you cannot take the weight. Then we need to convert phosphoric acid into any one of the precipitate. Tell me, in qualitative analysis, what PPT we got? You just refer it. In qualitative analysis, there also we got phosphoric acid. Ammonium molybdate. No, what is the reagent should be added? Ammonium molybdate. Right. So this phosphoric acid should be treated with ammonium molybdate to form ammonium phosphomolybdate, which is LOPPT. That means now here step is same. We got phosphoric acid. That phosphoric acid should be treated with one ammonium molybdate. It gives the ammonium phosphomolybdate, that is a PPT. That PPT is washed, dried, and it is taken weight. Or there is another option. Now this phosphoric acid treated with magnesium salt, particularly pyrosalts. Magnesium pyrosalts, it forms the magnesium pyrophosphate, that is also PPT. That magnesium pyrophosphate is a PPT. It can be washed, it can be dried, it can be taken weight. So therefore, based on either ammonium phosphomolybdate, you can get the percentage of phosphorus. Even by taking the magnesium pyrophosphate, you can get the percentage of phosphorus. Okay. So therefore, now you can take like this: phosphoric acid H3PO4, which is one treated with ammonium molybdate. What is the formula? NH4 twice MOO. It is a what it forms? Ammonium phosphomolybdate, right? NH4 twice. Twice or thrice? I think thrice. Thrice. PO4. 12 MOO3. Okay. This is a ammonium. Formulas are important, don't change. Phosphomolybdate. In Deepika? Okay. So ammonium phosphomolybdate, what is the color of the PPT? Yellow PPT. Next. Or else this phosphoric acid also treated with magnesium salt or pyrosalts. It gives Mg2P2O7. It is a white PPT which is called magnesium pyrophosphate. ನೋಡಿ ಫಸ್ಟ್ ಪಿ ಯು ಸಿ ಓದ್ತಿರುವಾಗ ನೀವು ಭಾಳ ಜನ ಸ್ಟ್ರಗಲ್ ಆಗೋದು ಇದೆ. ಕ್ವಾಂಟಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸು 99% ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. 1-2 ಎಕ್ಸೆಪ್ಷನ್. ಕ್ಲಾಸಲ್ಲಿ ಒಂದು 70 ಇದ್ದರೆ ಹಾರ್ಡ್ಲಿ ಒಂದು 2-3 ಮೆಂಬರ್ಸ್ ಮಾಡ್ಬೋದು ಅಷ್ಟೇ. ನಾಟ್ 4-5, ನಾಟ್ ಈವನ್ 4-5 ಆಲ್ಸೋ. ಅಷ್ಟು ಡಿಫಿಕಲ್ಟ್ ಫೀಲ್ ಆಗೋದು ಇದೆ ಕ್ವಾಲಿಟೇಟಿವ್ ಕ್ವಾಂಟಿಟೇಟಿವ್. ಇವಾಗ ಡಿಫಿಕಲ್ಟಿ ಆಗಲ್ಲ ಅಂದರೆ ಆಗುತ್ತೆ ಇವಾಗೂ, ಓದಿಲ್ಲ ಅಂದರೆ ಆಗುತ್ತೆ. ಓಕೆ, ರೈಟ್. ಸೊ ದೇರ್ ಫಾರ್ ಮ್ಯಾಗ್ನೀಷಿಯಮ್ pyrophosphate, it is also white PPT. Now you can get the percentage of phosphorus in terms of this. Okay, it is based on question. What question is given? For example, I wanted to calculate percentage of phosphorus in terms of this. Tell me. Now percentage of phosphorus equal to, now ammonium, phosphomolybdate. There are how many phosphorus? 1. So what is the mass of the atomic mass of the phosphorus? 31 divided by, then what is the molecular mass of the ammonium phosphomolybdate? So it is 1877 into mass of ಎಷ್ಟು ಸಿಂಪಲ್ ಇದೆ ನೋಡಿ, ಸೋ ಸಿಂಪಲ್ ಇಟ್ ಈಸ್. ಇದು ನೆನ್ಪಿಟ್ಕೋಬೇಕು ಮತ್ತೆ. 1877 ಯಾವುದೋ ಒಂದು ಬರ್ಡೇಗೆ ಮ್ಯಾಚ್ ಮಾಡಿರಿ, ನಂದಲ್ಲ. ಹೌದು, ಇಮಿಡಿಯೇಟ್ ಕೌಂಟರ್ ನನ್ನ ಮೇಲೆ ಇರುತ್ತೆ. ಸ್ಟೂಡೆಂಟ್ಸ್ಗಳು ಭಾಳ ಈಸಿಯಾಗಿದೆ ಟೀಚರ್ಸ್ ಮೇಲೆ ಕೌಂಟರ್ ಮಾಡೋದು. Tell me, in terms of magnesium pyrophosphate. So here how many phosphorus? 2 phosphorus. So 1 phosphorus mass is 31, 2 is 32. 62. Okay, divided by ಮಾಡ್ತೀರಾ? ನನಗೆ ನೆನಪಿಲ್ಲ. 222 into mass of Mg2P2O7 divided by mass of organic compound into 100. See, sometime in question they will give the mass of the ammonium phosphomolybdate. If they give the mass of the ammonium phosphomolybdate, use this formula. If they give the mass of the magnesium pyrophosphate, use this formula. ಎರಡು ಮಿಕ್ಸ್ ಮಾಡಿ ನೀವೊಂದು ಫಾರ್ಮುಲಾ ಮಾಡಬೇಡ್ರಿ, ಅದು ಭಾಳ ಈಸಿ ನಿಮಗೆ. ನಿಮ್ಮದೇ ನೀವೊಂದು ಫಾರ್ಮುಲಾ ರೆಡಿ ಮಾಡ್ತೀರಿ, ನಾವು ಯಾರ್ದು ಫಾಲೋ ಮಾಡಲ್ಲ ಅಂತ. ಮಾಡಲಿಲ್ಲ ಅಂದರೆ ಇನ್ನೊಂದು ವರ್ಷ ಇಲ್ಲೇ ಕೂತ್ಬೇಕು, ಇನ್ನೊಂದು ವರ್ಷ ಇಲ್ಲೇ ಕೂತ್ಕೋಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಹೌದು ತಾನೆ? Right, so this is how estimation of phosphorus by Carius method. Now see, as I told you, estimation of hydrogen, estimation of carbon and sulfur, all halogens and phosphorus, exactly the same method, Carius method. Okay, in all Carius method, even Levix method also same formula will be there. Okay, so I think till here no confusion will be there unless you forgot ಫಾರ್ಮುಲಾಸ್ ನಂಬಿದ್ರೆ ಏನು ಕನ್ಫ್ಯೂಷನ್ ಇಲ್ಲ. ಬಟ್ ಮೆಜಾರಿಟಿ ಸ್ಟೂಡೆಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ ಇನ್ ಎಸ್ಟಿಮೇಷನ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಓನ್ಲಿ. ಬಟ್ ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ಮೆನಿ ಕ್ವಶನ್ ಕಮ್ಸ್ ದಟ್ ಓನ್ಲಿ, estimation of nitrogen. So therefore this estimation of nitrogen, it is also so simple, but you need to understand it, not in this way, it is different way, right? So estimation of nitrogen, we have two methods, one Dumas method, two Zeldal method. Okay, so next write estimation of nitrogen. So it is of two types, two methods, one Dumas method, two Zeldal method. Zeldal's method. Okay, K silent. Okay, Now see here, the basic difference is, now why two methods? One ಸಾಕಲ್ಲ, one is enough, no? One ಇದ್ದರೆ ಕನ್ಫ್ಯೂಷನ್ ಇರುತ್ತೆ ನಮಗೆ, two ಇದ್ದರೆ ಮತ್ತೆ ಹೌದು ತಾನೆ? But two is required. Difference is, in one method the nitrogen present in the organic compound convert into dinitrogen, right? In another method, the nitrogen present in the organic compound convert into ammonia. It means you take organic compound, heat organic compound, if it has nitrogen, that nitrogen may come out as a N2 gas. Sometime that nitrogen may come out as a ammonia. That's what, if nitrogen come out as a N2 gas, that is used humus. Remember dinitrogen humus, DD match ಆಗುತ್ತೆ. Next Zeldal method, ಅದಕ್ಕೆ ಯಾವ್ದು ಮ್ಯಾಚ್ ಆಗಲ್ಲ, ಅಮೋನಿಯಾ ಬಿಟ್ಕೊಳ್ಳಿ, right? So therefore, if organic compound containing nitrogen which is converted into dinitrogen, humus method used. If it is converted into ammonia, Zeldal method can be used. Okay, now let's see humus method. Okay, so right, first point is, in this method this is only first important question. In this method, nitrogen present in the organic compound, nitrogen present in the organic compound converted into dinitrogen, that is N2, dinitrogen N2. Okay, now let's see what is the process. So process is so simple, it is as like Levix method. Okay, Rajeshwari, Levix method ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಹೇಳಿ, ನನಗೇನುಗೋಸ್ಕರ ಮಾಡೋರು ಗೊತ್ತಂತೀರಾ? So in Levix method we estimate the hydrogen and carbon, no? Okay, how? Known mass of organic compound is, it is heated with copper oxide, CuO. That copper oxide oxidizes carbon to carbon dioxide, hydrogen to water. Here also same. Apart from that, copper oxide can also oxidizes nitrogen to nitrogen oxides and nitrogen also. The organic compound containing, nitrogen present in organic compound get converts into N2 gas as well as oxides of nitrogen. Those oxides of nitrogen further again treated with copper metal, which converts into finally nitrogen gas. Okay, that's the point. Okay, then now finally you will get the nitrogen gas here. In this method, when you treat it with copper oxide, you will get the gases like carbon dioxide, you will get the gas that is vapor water, you will also get nitrogen gas. Then how to separate this? You need not to separate anything. You pass all the mixture of gases through the anhydrous potassium hydroxide. That anhydrous, it is not solution, anhydrous KOH absorbs CO2. It also, since anhydrous, it also absorbs water. Therefore anhydrous KOH absorb the CO2, it also absorb the water. Then what is the left? NO2. NO2 gas will be left. That NO2 gas is, it is collected over water. It is passed in water and you will get so on the over the water, N2 gas will be there. That N2 gas collected over water and its volume can be measured. Since it is a gas, the volume can be measured. From the volume of the nitrogen gas, then further percentage of can be calculated. Okay, so this is actually process till collection of N2 gas. That means volume can be measured. The next calculation starts from there itself. Okay, so write in short way, in this method, in this method known mass of organic compound is, known mass of organic compound so heated with copper oxide, heated with copper oxide. Tell me, which oxidizes what? Which oxidizes carbon to carbon dioxide, hydrogen to water, and even nitrogen present in organic compound also converts into what? N2 gas plus oxides of nitrogen. Why oxides of nitrogen? Because there is a CuO. You will get N2, along with N2 oxides of nitrogen. Then we want, what are the oxides of nitrogen? N2O, NO, N2O3, N2, NO2, N2O5, etc. These are the oxides of the nitrogen. Okay, then now these all oxides of nitrogen, they are heated with copper metal. So you will get N2 gas, copper metal converts into copper oxide. Then finally you will get N2 gas. Now tell me, then we have mixture of gases. What are the mixture of gases produced? CO2 is produced, comma, H2O is produced, and N2 gas also produced. These are the mixture of gases. Now these mixture of gases are passed over anhydrous KOH. This anhydrous KOH absorbs both carbon dioxide as well as water. Then what is the left behind? N2 gas. Therefore, it is passed over anhydrous KOH. Which absorb, not adsorb, AB, which absorb CO2 and H2O. Now pure nitrogen gas will be left. Okay, so this N2 gas collected over water, and what is measured? Since it is a gas, volume is measured easily. Collected over water and volume is measured. So this is the experimental information. Okay. Now since it is a quantitative analysis, so we have important not experimental information, quantitative formulas are important for us. Okay, fine. Here, so till here we understood that nitrogen gas is collected over where? Water. So nitrogen gas is collected over the water, not ammonia. See, usually ammonia not collected over water. Why? Because ammonia reacts with water to form ammonium hydroxide, but not this N2. N2 does not react with water. Okay, so therefore now N2 gas is collected over water. Now let us take let the mass of organic compound. How much? W gram. Okay, let the mass of organic compound W gram. Next, volume of N2 gas collected over water. I will take V ml. So V ml gas is collected or it is formed. Next, Now tell me, what is the pressure? Pressure of N2 gas. N2 dry gas, wet gas, or moisture gas? It is a moisture gas because we are collecting over water. Therefore, that is a, let us take P. This is a P moisture. Next, volume and pressure over. Next is temperature. Now let us take temperature of reaction. It is a T degree Celsius, okay, but we should convert into Kelvin. That means it is a T plus 273 Kelvin. Okay, now let us see calculation of volume of N2 gas at STP. Now see here we got volume. What is the volume of N2 gas is collected? And one more, here only take surface tension or aqueous tension, because it is in aqueous medium, no? Aqueous tension equal to small a mm of mercury, and this is a p mm of mercury. Can you tell me what is the pressure of dry N2? Moisture N2 is P, dry N2, pressure of the moisture gas minus aqueous tension, no, mm of mercury. So pressure of dry N2 equal to pressure of the moisture gas minus aqueous tension, we'll get the dry N2. Okay, now let's say calculation of volume of N2 gas at STP. Tell me why we have to calculate STP? We will get the relation between volume and mass if you have STP. Yes or no? What is the relation between volume and mass? If it is STP, we know that 22,400 ml, right? 22,400 ml of any gas is equals to its molar mass, no? Molar mass of nitrogen is 28 gram. That means if you know the volume at STP, you can convert into mass. Therefore, I want, now we got the volume, of course, this volume has to convert into STP volume. So how do you calculate, how do you convert? This is the calculation of volume into gas STP. Now here I will take two conditions. One is a experimental condition. Second one is STP condition. Tell me, first one, experimental condition. Let us take P1 pressure, V1 volume, T1 is temperature. What is the P1 pressure? What is the P1? P moisture minus A mm of mercury. Experimental condition means whatever we got here information, that is experimental information. Next, volume. What volume we got? Let us take VML. T1. What temperature you have taken? T plus 273 Kelvin. Okay. This is the experimental conditions. Next is STP condition. Let us take P2, V2, T2. Tell me, at STP what is the pressure? 760 mm of mercury or nothing but 180 mm pressure, no? Since we have taken mm, take mm. 760 mm mercury. V2 we have to calculate. That will know. Calculation of volume at STP. It means we need to convert this volume into that volume. And T2, 273 Kelvin, standard temperature. So therefore, now tell me, by using this information, can you calculate STP volume? So can you calculate the STP volume? So we have from ideal gas equation. From ideal gas equation, P1 V1 by T1 equal to P2 V2 by T2. Okay, so P1 equal to P moisture minus A aqueous tension into V1 is nothing but V by T1 is nothing but T plus 273. This information we will get it by experiment. Then P2 equal to 760, we know it, into V2 we have to calculate T2 273 Kelvin. Then finally V2 is equals to, we want then P moisture minus A into V into 273 divided by T plus 273 into 760. This is in ml. Okay, what is this? Volume of nitrogen gas at STP. Okay, but actually what we want to calculate? Percentage of nitrogen. How do you calculate percentage of nitrogen unless you know mass, right? So therefore calculation of percentage of nitrogen. Okay, then see here, we know that it is a 22,400 ml of any gas or nitrogen gas, N2 gas, which is equals to how many grams? 28 grams of N2 gas. Yes or no? So that means, so this much volume is equals to this much mass. But how much volume we got? V2 volume. At STP we got V2 volume is equals to, or V2 ml is equals to, what is the mass? So tell me now, mass of N2 is equals to 28 divided by 22,400 into V. But actually we want percentage of nitrogen. So percentage of nitrogen equal to mass of nitrogen divided by mass of the organic component into 100. That's it, no? So therefore 28 by 22,400 into V. What is the V? Volume of N2, no? Or else you write volume of N2 at STP divided by organic compound into 100. Actually problem ಬರೋದು ಇದ್ರ ಮೇಲೆ, ಇದು ಬರ್ಬೋದು, ಇದೇ ಭಾಳ ಜಾಸ್ತಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಬೋದಂದರೆ, ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ ಸ್ಟಿಲ್ ಸಿಂಪ್ಲಿಫೈಡ್ ಫಾರ್ಮುಲಾ ನೋಡಿ, ಇದಂತಿರಲಿ, 20 T0 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತಾ, ಇದು 28 by 224 ಅಂದರೆ ಏನು ಬರುತ್ತೆ? 28 by 224 ಅಂದರೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 8 approximately 8. Okay, so therefore it is a volume of N2 at STP divided by 8 into W, not into 100. Already simplify ಮಾಡಿದ್ವಲ್ಲ. So problem ಕೊಟ್ಟರೆ ಇನ್ನು ಇದು ವಾಲ್ಯೂಮ್ ತೊಗೊಂಡು ಯು ಡಿವೈಡ್ ದ ವಾಲ್ಯೂಮ್ ವಿತ್ 8 and W, you'll get the answer. So this is how you can calculate a percentage of nitrogen. ಅರ್ಥ ಆಯ್ತಾ? ನೋಡೋಣ ಸರ್, ಏನು ಡಿಫಿಕಲ್ಟ್ ಇದೆಯಾ ನೋಡಿ. ಎನಿ ಡೌಟ್ಸ್? Okay, next is estimation of nitrogen by Zeldal method. Zeldal method. See in question, they will give the volume of N2 gas. The volume of N2 gas liberated by Dumas method so and so, something 10 ml, 20 ml, 30 ml. And they will give the mass of organic compound 2 gram, 5 gram, 0.25 gram. Most of the time they will give less than 1 gram. Like 0.2, 0.3, 0.4, like this, W will be given. W will be given, volume will be given. So you can get very easily percentage of nitrogen. Okay. Now next is Dumas method, that is Zeldal method. Tell me, like similar to Dumas method, Zeldal method is used to estimate nitrogen, but what? But when nitrogen present in organic compound has to convert into what? Ammonia. Right? Therefore, in this method what? Nitrogen present in the organic compound converted into ammonia, and ammonia mass is estimated. From the ammonia mass, this can be calculated. Okay? Therefore, write first point. In this method, nitrogen present in the organic compound is converted into, in this method, nitrogen present in the organic compound is converted into ammonia, Okay, next. Then here, this method generally it is used to estimate the nitrogen present in particularly food, fertilizers, soil, etc. So nitrogen present in the food, nitrogen present in the fertilizer, soil, food, like food compounds like amino acids, proteins, like biomolecules. So this method can be used. Next, one more important point, where this method cannot be used. See, one important point, this method cannot be used to estimate the nitrogen where nitrogen present as a NO2, nitrogen present as a NO, NO2, NO, even diazonium salt, and even heterocyclic compounds. In these 4 compounds, this method cannot be used. Okay, that is also one important point. Questions are previously asked. This method is not used to estimate the, this method is not used to estimate the nitrogen present in the form of NO2, NO, disonium salt and heterocyclic nitrogen compounds. Heterocyclic nitrogen compounds. For example, if the benzene containing nitrogen in the form of NO2, nitrobenzene, so can this method used? No. Nitrobenzene not, because NO2, if the benzene containing NO, no, or if nitrogen present disonium salt, BDC, benzene disonium chloride, not, because it converts into N2 gas, no. Next, if the nitrogen present like heterocyclic ring, pyridine or pyrrole, pyrrole, these are the heterocyclic. Therefore, if the nitrogen present in these forms, it cannot be used to estimate in this method, because to estimate this method it has to get ammonia, no, ammonia has to formed. Here in these cases ammonia will not be formed. Okay. Then next is, what is the experimental information? See, in this method organic compound is heated with okay, so it is heated with, of course, HNO3. Tell me, when organic compound is heated with one second, not HNO3, H2SO4, H2SO4. So what happened? Organic compound is heated with H2SO4 in the presence of potassium sulfate and copper sulfate, where potassium sulfate, copper sulfate are the, actually copper sulfate is a catalyst, copper sulfate and potassium sulfate. This potassium sulfate increases the boiling point of sulfuric acid. Okay, now tell me, this organic compound containing nitrogen, so what happens? This nitrogen containing organic compound reacts with sulfuric acid, you will get ammonium sulfate. This is the first product, right? Organic compound containing nitrogen which is treated with sulfuric acid in presence of K2SO4 copper sulfate, will get ammonium sulfate. That means nitrogen present in the sulfuric in organic compound, sulfuric acid, ammonium sulfate. Sulfate is here, this nitrogen converted into ammonia, ammonium sulfate. Okay, now here important is K2SO4, the previous question was appeared here, and copper sulfate. K2SO4 potassium sulfate, it increases the boiling point of sulfuric acid. Copper sulfate act as catalyst for H2SO4. Now tell me, it is ammonium sulfate, but actually we want ammonia, no? Then this ammonium sulfate, it is treated with sodium hydroxide. Ammonium sulfate plus sodium hydroxide. Tell me, what is the product? Sodium and sulfate. Sodium sulfate, ammonium ion plus OH. Ammonium hydroxide, that can be written ammonia plus, tell me, of course water will be formed, and Na2SO4. Got it? Balance, is it balanced? Okay. Therefore, then finally we got ammonia by the sequence of reactions. Okay, but here again one small twist. This ammonia cannot be directly again estimated, cannot be used to estimate nitrogen directly. Okay, then what here we do is that ammonia first reacts with sulfuric acid. ನೋಡಿ ಒಂದು 2 ಪಾಯಿಂಟ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Okay, this is ammonia, right? We got something ammonia. Okay, it can be taken out. Now that ammonia should be treated with what? Excess of sulfuric acid. Why? Ammonia is a base, sulfuric acid is a acid. Acid reacts with base, it forms salt and of course water. Therefore the ammonia here formed, which is treated with excess of sulfuric acid, H2SO4. It must be excess. I'll tell you why excess. Okay, then now ammonia reacts with excess of sulfuric acid. What it forms? Ammonium sulfate will be formed. No, ammonia plus sulfuric acid, ammonium sulfate, which is a salt, then plus tell me, plus what do you get? There is a excess of sulfuric acid. No, so and there excess taken. No, we have taken excess. So when you take excess of sulfuric acid, the complete sulfuric acid will not used, right? Some part of sulfuric acid used and remaining sulfuric acid will be left, right? Now whatever the sulfuric acid left, that sulfuric acid, now this is a left sulfuric acid, now it is titrated with sodium hydroxide. Now tell me what you get? Na2SO4 plus H2O, salt and water. ಓಕೆ, ನಿಮ್ಗೆ ಇಲ್ಲಿವರೆಗೆ ಅರ್ಥ ಆಗಿರುತ್ತೆ. ಇದೇ ಒಂಥರ ನಾನು ಈ ಥರ ಬರಿತೀನಿ ನೋಡಿ. ಅಮೋನಿಯಾ ವಿ ಹ್ಯಾವ್, ಇಟ್ ಈಸ್ ಎ ಬೇಸ್, ಲೈಕ್ ಐಲ್ ಟೇಕ್ ದಿಸ್ ಅಮೋನಿಯಾ, it is ammonia and this is base. Now it is reacts with excess of what? H2SO4. Now out of now this much H2SO4, let us take this part. So only this part of sulfuric acid is enough to reacts with ammonia. So we'll get this is a what? Salt, right? What salt it is? Ammonium sulfate salt is formed. Then still there is a sulfuric acid. No, this is sulfuric acid, which is called what? Left. Now that left sulfuric acid now treated with what? This is a salt, of course, let it be. Now this is a left sulfuric acid. Now it is treated with NaOH. Okay, enough NaOH, so that this complete sulfuric acid is converted into what? Okay, so this is, you will get something Na2SO4 and this is ammonium sulfate. Okay, now what we are doing actually? Why we are doing all these things? We wanted to, now see, we wanted to ammonia, we wanted to calculate ammonia, but we are not calculating ammonia directly. What we have done, that ammonia is converted into what? Ammonium sulfate by with sulfuric acid. Now here we can take what? Sulfuric acid left. This can be measured. Now let's left sulfuric acid, we wanted to calculate left sulfuric acid. How much left? If you calculate left sulfuric acid, can you calculate used sulfuric acid? Indirectly barutte, right? Used sulfuric acid. Therefore now percentage of nitrogen is equals to, it is a 1.4 into N into V. N is a normality of sulfuric acid, V is a volume of sulfuric acid. Which sulfuric acid? Which is used for, left nothing but which is used for neutralization. Yes, this is the volume of sulfuric acid that is used for NaOH, which is also called neutralization. Okay, so N into V divided by, in calculation what do you get? W. Okay, not 100, not, it's simplified. This is the formula you'll get finally. So normality of sulfuric acid, volume of sulfuric acid used for neutralization, or else write clearly here. N is equals to normality of H2SO4, V equal to volume of H2SO4 used for used for neutralization. ಅದಲ್ಲ, ಇಲ್ಲಿ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ವಿತ್ NaOH. So W is a mass of the organic compound. Okay. So once you read, I'll repeat once again. That's it.